Welcome everybody to the next DevToberfest session. And the topic for today is what's new in the ABAP RESTful application programming model, shortly RAP. My name is André Fischer. I'm product manager in the ABAP development group. And yeah, I would like to show you some of the latest features we have added to the RAP framework. So what will I talk about? So first, I will show you the SAP Fiori Elements Feature Showcase app that has been built with RAP. So there is a new version out now with the release 2308. And so that's for the beginning, to show what features can now be built using backend annotations. And then we will switch to the controlled sub-LOE, so the logical unit of work, and what we have added here so that you can make use of these features that we have developed for the RAP framework. Then another topic will be the background processing framework, in short BGPF. So that is a very cool new feature that allows you to start asynchronous processing. And that's something where what people have been waiting for quite some time. And we will finish our session with the topic of local events. So events can now also be consumed locally, and how customers can extend events that are delivered by SAP. Let's start. So the SAP Fiori Elements Feature Showcase with RAP. So this showcase has been developed here by my colleague Jessie, and she always writes a blog post about this when there is a new version out. So we can here have a look at this. So it always opens in the other window. Okay? And it's nicely described what you can use there. So for example, what the new feature is that you can now define for a RAP business object a leading entity. And the nice thing is now that this leading entity shows up in ADT in the beginning, and this is quite helpful if you have larger RAP BOs that contain lots of entities. So, and then you can just double click on this and use the preview. So we can just walk through a few of those features that we now have. Besides this leading entity stuff, we have now can convert time zones, or it's possible to have mandatory action parameter. And if you click now on such a link in the blog post of Jessie, you will see that you will end up in the README of the GitHub repository, and there you will find then lots of information about the new about this feature. And also a cool feature is here. If you search now, if I press now Control F, I can search here for these bulbs, and I can navigate here locally, and you can then walk through that document and see all these and see all these new features. So it's really nice what we see here, like quick views that can be built from the backend side. So it's just what you want. If you want to use that, right? We will open our Eclipse. Let me check here. Okay, here's my Eclipse. And you have downloaded this here in a package. and then you will find the service binding. And here also this now this cool new feature of the root entity. If you double click on that, it will open the preview of this app, and that would then allow you to walk through all these features that are described in detail in that blog post and in the very informative README document. Good. So that let me go back to our presentation. So that's the UI side. So we'll now switch to the backend part, and I would like to start with this control SAP logical unit of work, because the rest of the features that I will present to you somehow depend on this or make use of that. When we look at the SAP LUV and the transactional phases we have, so we see that there's usually a modify phase. So the user is working in UI, is changing data, buffers are updated, and then finally, if everything is fine, the user presses the save button, and then either the data is committed to the database in the end, or it might be that something goes wrong and it rolls back. And the problem in the past was that there could be situations where the developer had to look at. So if, for example, implicit commits take place, right? And if maybe somebody has already performed changes to the database, and if then such an implicit commit took place, this data was persisted. So that's not new, right? But what now RAP brought to the table was a clear orchestration and control of the SAP logical unit of work. So RAP, so we have 3 phases. So we have the injection phase, and then we have an early save phase and a late save phase. Okay, looking back, we would maybe nowadays rename those phases, because the early save phase is more preparation of the save phase, and the late save is the real save. So because that's this point of no return when the data is either committed to the database, or the system would, let's say, stop with a dump and everything would be rolled back. And this is now something we really achieved here with RAP, that the developer is, he has now not all these opportunities he had with classical RAP, where he had to look, okay, am I using the update task correctly and so on? So you cannot use it anymore, because this is now not possible with the ABAP Cloud programming model. And what you gain here is that what you are going to develop is really stable, and that's the big advantage. And we want, and it's what's now possible, that what has been developed for the RAP framework can now also be leveraged from in other implementations. So here again, you see there is this modify phase that spans the interaction in the early save phase, and the late save is really this save sequence. What we can do now is, if you write a class, for example, not a RAP-BO, it is possible to explicitly set this transactional phases within a class that has been delivered by us, CL ABAP TX. And if you use that in your code, you can, there are two static methods. You can use the method modify, and that would signal the framework that we are entering the interaction at early save phase. And there we can do all those things that are allowed in that phase. And we can then later on enter the late save phase of RAP by running this static method save. And then, for example, this would lead to a dump if you would do something that violates this contract. And that's the big advantage. You can now leverage these stability contracts that we have introduced with RAP. Let's have a look here at the code. So you would, in your code, use this modify method. And then, this is commented out here, if you would now perform a modify DB tab from some data, that would be a violation, and that would end up with a dump. If you, however, have set entering the save phase, it would be allowed to modify the data as planned. And this is now the nice thing that you can follow. And where can we use that as well? So there are APIs that are available from SAP, lots of them in S/4HANA, but also in the naked Steambank, you would, for example, find this API that allows you to send mails, also a new feature. So, and these APIs are now classified. And if you use here F2 and check the send async method, and you would find that there is a transactional contract mentioned. And this tells you, okay, I'm only allowed to use that method in the save phase. And if you want to read about this SAP LOV in more detail, I can really recommend the blog post from my colleague Renzo Koller. Just click on that. And here, just a 5-minute read, and it really describes in very detail how the SAP logical unit of work works. Let's now switch to a demo. So here in my clips, I've prepared class. You remember this screenshot of the classified API. So I'm going here to use that mail API, and I will just send a mail. And as you see here, I'm entering the save phase at this point, and would then, after that, perform this async call, which is only allowed in the save phase, but not in the modify phase. So if we press F9, we see, okay, that the mail has sent, and I can switch to my Outlook. One moment. Too many windows open. So we see here we just received that email. So far so good. So we are now trying. What I would like now to do is I will comment out this here. Okay, here we now get the short dump that I was expecting. And we see also this in the feed reader that this statement is not allowed. Okay. The background processing framework is the next topic. So we saw that in the RAP framework, everything is nicely controlled, but from time to time, you would like to do something asynchronously. You would like to, for example, start a longer running process, or would do something where the user should not wait on. So asynchronous start of asynchronous process is a nice thing. And for this, we now have developed the background processing framework. So it's not totally new. So it allows, as said, asynchronous processing. And technically, it's a wrapper around the good old BGRFC. But in contrast to the BGRFC, it's quite easy to configure. So there is just in an on-prem system, you would have to more or less only create one RFC destination for that. In a cloud-based system, this is done by us for you. And how does it work? So there is a save for execution method. So this factory class here. So you can set a name for your operation, and then you are using you're creating an instance of a class which implements certain interfaces that are developed by us, and you can provide data to that call, and then it's just saved for execution. Once a commit work takes place, the execution is started. So that means this commit work can either be started explicitly, if you do that via a class, or if you do it from within the RAP framework, this commit work is implicitly performed by the RAP framework after the data has successfully been saved. So we have now two use cases. One is to use the background processing framework inside RAP. So you have a RAP app, and you want to, let's say, for example, have an action button, and that should now start this asynchronous processing. And then this save for execution method would be called, and that must be called in the save sequence. And the commit work is triggered then for you by the RAP framework. The other way around is you make use of the background processing framework, and then you use RAP in that call. So you would, for example, have a class that there you want to modify an entity. And please note, if you implement this class, the framework of the background processing framework automatically sets the start of a modify phase. And only later you could, for example, specify that you're entering the save phase. And that would then allow you, for example, to call this classified API that I showed to you, so that it's this send async. And yeah, this we will also show. Switching back to Eclipse. So there is a method. It's called send email control, and this implements certain interfaces that have been provided to you by us. And here I'm in that implementation. I'm performing this read entities. Remember the screenshot. Then I do something which, let's say, simulates that it takes long. And this, for example, would perform an implicit DB commit, which is allowed in the modify phase. And finally, I'm modifying the data, and then I'm entering the save phase, and I would then send an email with the data that has been updated there, and that would this can now be run in my RAPBO. So I have a RAPBO, and that has a behavior implementation class. And if we look here, we have in the save sequence, in the save modified phase, if I create something, then I'm instantiating here this class. I'm saving this for execution, and if everything goes, if the save phase goes through, it would start sending out an email. And this we are looking here later on, this race event. That's something I would like to show later to you. So what I'm now starting my app. It's a small RAPBO, so we'll see that later in TechEd. So it's basically we used also in our hands-on sessions, in a hands-on session, also in one of our jumpstart sessions. So I'm now creating something, right? So I'm entering the price. So that should simulate an online shop, and just press create, and this object 21 is created. We can now have a look at our inbox, and we see here that the email has been sent exactly with that number 21 in it, so in the subject. Yeah, that shows how we can use the background processing framework from within RAP. And now we will have a look at the other way around. So I'm now use RAP in BTP. So I'm press here F9. Then what would happen is that I'm selecting here now an order with 19. I can also change this to 21, right? So we have just created this order. And then it would enter something in the notes here. I'm sending the mail, so I'm just press F9. That shows me, okay, now that's the BGTF demo control. So I've called my RAPBO from the outside, and I can also do here a refresh. And you see here that in the notes that the data has been updated via my EML call. Good. Then we are continuing, and we will have a look at events and about local events and how to extend events. So local events is something which we have now introduced with 2308. And what does this mean? So we can now raise events. Raising events was already possible a longer time, but so far we only supported remote events that were pushed to the event mesh. But you might want also to use events locally. So for example, the RAPBO that we have just seen that could, for example, raise an event after, let's say, the order has been accepted. And how can we consume those events? For this, we would have to implement a so-called event handler class. And the syntax is the following. You create a class and then use here the statement for events of and then the name of the RAPIO. And if you would create that then and activate it, you would see in the properties that ADT shows this as an entity event handler. And we can now again go to Eclipse, and we will see here an event consumer, and you know here I have here two packages. So this is a package that is part of a software component X01, and the other one is of a base object. And I've now created here an event handler class. And what does this show? Since this RAPIO resides in software component 1, it has been released here. So you see here that our, if we look at the behavior definition, our shop RAP business object has an event order accepted, and that has some parameter, and this parameter is contains the UUID, that's always part of an event, but also the order ID, so the semantic key. And we look at the there is an interface, and there we have specified that this event can be used. And if we check the properties, the API state, we see that the interface of our behavior definition has been released for extensibility, that's the C0 contract, and also system internally, that's the C1 contract. So we can now make use of that event in another software component, and here that means in our behavior, in our event handler. So the event handler more or less listens for new events. And what do we do to show? How can I now show you that an event is really is coming here? So we see here that there are two methods. One is for the event order accepted, and there is a second method which is used for a second entity, for a second event, and we will have a look at this later on. And then it inserts now data in it, or maybe I show it now because you will see the result. So in addition, I have created a behavior extension. One moment. So the behavior extension defines a so-called managed event or derived event based on the original event. And here the trick is we can define a new parameter, this time not an abstract entity as usual in an event, but this is a view entity. So the view entity has to have the same key field, and other than that, it could have other fields. So, but here we are now using this to retrieve more data from our from the events, not only the order ID, but for example, the order item price. So, and this should show you, if you as a customer, you will see an interesting event from SAP in S4, but you would like to retrieve more data from that event, you can use this mechanism to create a new event based on the, or extend this event from SAP and add your custom payload to that. And that's a feature that was asked us by several customers. So we see here, this is the additional payload. And what I'm doing now is, it has already worked. So we can have a look at the table here. So that's the table that we are entering our data. And we see here that data has been entered for the order ID 20 and 21 that I've been creating. For example, also my user is entered, and the timestamp can be added here as well. So again, that's what I showed, the result of those derived events. So you create an extension, and you extend the behavior of the original RAP business object, and you can define a so-called managed event based on the existing event from SAP. Here I'm using a Z object. So it shows that this can also be used by partners. And the parameter is here the view entity that has the same key field, so that the data can be passed to that. And it allows, as said, customers to extend events from SAP with their own payload, and that can then be consumed. So that was the demo that I showed there. So I hope that you found these features interesting. And yeah, when this video will be made online, I will see whether there are questions for that. And you can try out a few of those things in also in the trial systems. Some stuff will only be available if you have your own steampunk system. Goodbye and have a nice day.